Bismillahirrahmanirrahim. Welcome to my channel Science and Engineering Knowledge Academy. I am Afnan Haider Khan. Today we are going to discuss modes of heat transfer. So before going into the modes of heat transfer, let's discuss what actually heat transfer is. So heat transfer is basically the, the thermal energy flow, the flow of the thermal energy from higher temperature towards the lower temperature. Or we would say that the thermal energy in transit due to the spatial temperature difference. So whenever in a space or in an area within a medium or between two medium there is a temperature difference, so there will be a heat transfer, right? Now suppose we have two temperatures T1 and T2, so the difference between them would give us the direction of the heat transfer. Now if T2 is higher and T1 is lower, so the heat transfer would take place from higher temperature towards the lower temperature. Now it is very important to understand that high temperature area and low temperature area. So now as you can see, if the temperature of these two things are equal, so there will be no heat transfer. Why? Because there is no temperature difference and there would be no flow of heat. There would be no heat transfer if this is equal. But if one medium is at a higher temperature as indicated and the other one is at a lower temperature, then the heat flow will occur, right? The heat flow will occur unless and until both have the same temperature, right? So what does that mean? That means that it's essential that the heat transfer would take place whenever there is a temperature difference. And if there is no temperature difference, right, between the two media or within a media, then there would be no heat transfer. So we come towards the conclusion: whenever a temperature difference exists in a medium or between media, heat transfer must occur. So that's the conclusive point. The conclusive point is that the heat transfer would take place, would have to take place, must take place whenever there is a temperature difference. And the flow will spontaneously takes place or occur from higher temperature towards the lower temperature. So it's very important to understand. Now how that heat flows from high temperature towards the lower temperature, so that's what we called the modes of heat transfer. So there are different modes of heat transfer in which basically the heat flows from higher temperature towards the lower temperature spontaneously. Number one is conduction, number two is convection, and number three is thermal radiation. So these are the three different modes of heat transfer through which the heat flows from higher temperature towards the lower temperature. Now these two modes of heat transfer require medium, right? They require medium for their propagation, for their flow. However, thermal radiations are EM waves. These are basically electromagnetic waves, and as we know that electromagnetic waves or electromagnetic radiations do not require any medium for their propagation. So the conduction and convection requires medium for the propagation, and the thermal radiation can take place with or without the presence of a medium. Now we are going to briefly discuss three of them, and we will one by one, and then we will discuss all of them in detail in our later lectures, in our coming lectures, right? Now you would have seen that whenever you hold an iron rod from one end, right, in your hand, and the other end put it on the flame, right, so it will start heating, right? The temperature over here would begin to rise, so that will become a higher temperature region. Now after some time it would quite difficult for you to hold this iron rod because you will feel the heat over here. Now what has happened? The heat has flown from higher temperature region towards this lower temperature region, right? Now how it takes place, why it takes place. So it takes place because here predominantly the mode of heat conduction is taking place. The mode of heat transfer, what we call conduction, is taking place. And that conduction requires medium because the molecules over here start oscillating and vibrating vigorously and actually transmitting that energy to the neighboring molecules, and that's how the energy flows over here and you will feel heat on your hand. So this is how you would basically be able to understand that this is A region, which is the A end is on the flame and B end is cool, which is hold over here. Now here the atoms becomes hot and the kinetic energy increases. Now the kinetic energy increases and that kinetic energy basically is transferred from this higher temperature gradient towards the lower temperature gradient because of the collision between the molecules. So these particles or these atoms when collide with each other, so they transmit energy to one another and ultimately the heat flows in this direction, right? As you can see here, the temperature is high, here the temperature is low, so there is a temperature difference. And as we have mentioned that the heat transfer or heat would flow whenever there is a temperature difference. Now in this case, the medium is there. Without any medium, if there were no particles over here, so the mode of heat transfer, what we call conduction, would have difficult to take place because for conduction, the molecule or atom to atom interaction is very much important, right? So that's why what we call conduction, right? That's why we call that, or we say that it requires medium for the propagation. Now, if you could actually see this, so there is a thermal energy source, right? And then these particles would actually gain the kinetic energy from this thermal source, right? Okay, now just watch this animation. Over here you can easily see that the kinetic energy has been improved and has been increased, and actually vibration has started, and the vibration actually goes on and on and on, and basically due to the collision, right over here you can see the particles have gained the energy and has collided, right? Now this, due to this collision, what's happening? The heat transfer is taking place from higher energy region towards the lower energy region, and eventually there is a temperature rise at the other end as well. Now this type of heat transfer requires a medium, as we have discussed and as we have mentioned already. The governing equation of the conduction heat transfer is this, and we are going to discuss this in our lecture 2 part 1 in detail. So for that you have to watch the lecture 2, and we are going to discuss what is the Fourier law of heat conduction and heat transfer. For that, please watch lecture number 2 in detail. Now conduction takes place in solid, liquid and gases, in all modes, in all state of matters, solid, liquid and gases, the heat transfer takes place. Now you can see that this is a pan where the heat transfer takes place through conduction, and here the woolen cloth has been used because it is an insulator, Now what is the purpose of insulator? Insulator are used because here the molecules or the atoms do not basically gain energy or do not transmit energy or conduct energy efficiently, right? So if this is the pan which is made of steel or any conducting material, so it will conduct heat, and if you use the woolen cloth, so it is an insulator, right? So here we comes to different materials which are conductor and insulator. Now conductor allows the transfer of heat while insulator resists the transfer of heat. Examples are copper and iron and wool and plastic respectively. As you can see that in winter we use the woolen clothes. Why? Because we want the our body basically to uh, to not to emit heat into the environment. We want to trap that heat close to our body, and we do not want that heat to transfer into the outer atmosphere, right? So that's why it gives us a proper insulation, so the heat produced by the body is trapped within that region, and it do not actually transfer to the outer environment. If there is no wool, so obviously the heat transfer would take place from the higher temperature towards the lower temperature in winter, right? So now from here we are going to move towards our next mode of heat transfer, which is convection. And in convection, basically the heat transfer again takes place due to the temperature difference from higher temperature towards the lower temperature. But in this case, it happens due to the actual movement of the fluid or the molecules. In the previous one, the molecules or the atoms were vibrating at their own position. But here, it would happen because of the movement of the molecules, right, from one place to another place, and that can only happen in fluids, right, in liquid and gaseous states. And this mode of heat transfer takes place due to two mechanisms, or based on two mechanisms. Number one is the diffusion, right? There is a random motion, molecular motion, due to which the molecule turns from a higher temperature gradient towards the lower temperature area or gradient. And the second one is the macroscopic motion or the bulk motion, the motion of the molecules by itself, right? Not due to the random motion, but with the flow of the molecules, right? And this happens only in fluids. Now if you see, so we have a hot egg in this example, and when the cool air from the surrounding touches the surface, so it becomes lighter, warmer, its density is reduced, and it moves up, right? So in this way, then more cool air comes in and takes away the heat in the form of convection, and hence the heat transfer takes place from the surface, between the surface, hot egg surface, and the air molecules, right? And the motion of the molecules, you can see, is there is that the molecules come in contact with the hot egg and then moves away, so the heat is taken by the motion of the molecules, right? Similarly, whenever we boil the water, so the hot molecules at the lower region of this pan moves upward, and the cool molecules downwards because of the density change. And in this way, the entire the entire water, or the entire water starts boiling at 100 degrees Celsius when the atmospheric pressure becomes equal to the vapor pressure. But how the heat transfer takes place, so this is due to the actual motion of the molecules and from one area to another area within the same medium, right? Here it was between the surface and the fluid. It was here in this case, it is within this, within a same medium, right? Within a same medium, the entire medium is water. Here we have a solid surface and then the air, so the heat transfer taking place between the two media. Now the term convection is customarily used when referring to this cumulative transport. So whenever we say convection, so whenever we are assuming that both the diffusion and the bulk motion is taking place, so we call it as convection cumulatively. But for the bulk motion of the fluid, we use the word advection, right? For the bulk movement of the molecules, we would call it as advection. And whenever advection and the random motion or the diffusion combine together, so we call it as convection. The governing equation of convection is this one, right? And we are going to discuss it in detail in the lecture 3, part 1. So please go to lecture 3 and watch it, the detail of convection equation in lecture 3. Now convection is of different types, natural convection and forced convection. Now again we have this hot egg. Now if you see, we are not blowing any air, the air comes in contact with the hot egg spontaneously, moving up spontaneously, naturally I would say, and the heat transfer occurs naturally, right? There is no external agent involved in it. Similarly, when the heat transfer between a cold soda and the air take place, so the warmer air come in contact with the heat transfer takes place from outside to inside, from higher temperature to lower temperature, and that's how the cool air moves down, and this process of heat transfer takes place quite free and naturally. But now what happens if we put a fan over here and blow the air in order to make the heat transfer more faster, more streamlined, right, and control it? So we would call it as forced convection by using some external force or external agents, right? So natural convection is caused by natural means such as buoyancy, as mentioned over here and mentioned over here in these two cases. So due to buoyancy, the heat transfer would take place, and that is quite a natural process. As far as the forced convection is concerned, so in forced convection, the flow is forced through external means such as pump, air. As you have seen that if you have a cup of tea, if you have a cup of hot cup of tea, right? So whenever you blow air through your mouth, right, through your mouth, so what happens? The heat transfer takes place more quickly, more rapidly, and this type of heat transfer or convection would be called as forced convection, because you are blowing air through the surface of this hot tea, and due to which the heat transfer is being increased. All right. So this is what we call convection, which takes place in fluid due to the motion of the molecules or the atoms, and that motion can be of due to diffusion, random motion, or it can be due to the bulk movement of the molecules. And the convection can be natural and it can be forced convection, right? And further, as far as its governing equation is concerned, so we are going to discuss that in detail in the lecture number 3. Now here it comes the final mode of heat transfer, which is radiation. And radiation are basically emitted by any body that is at a non-zero temperature. What does the non-zero temperature means? So by the non-zero temperature, we means anything above 0 Kelvin, which is minus 273.16 degrees Celsius, right? So above that, if there is any body, so it will emit radiation, right? Now, the energy of the radiation field is transported by electromagnetic waves, which we alternatively call photons. Now, as I have mentioned that electromagnetic waves do not require medium for their propagation, and this is evident from the fact that the solar energy or the solar radiation comes to the earth because of the electromagnetic behavior of the waves or the radiations, and there is a space between the sun and the earth, and it still travels and reaches to us. It's because it did not require any medium for the propagation, right? So thermal radiations do not require any medium for the propagation. Now, while the heat transfer takes place by conduction and convection, which requires medium, the radiation does not require any medium. In fact, radiation occurs more efficiently in vacuum, right? Because there is no obstacle, there is no other source of magnetism or electricity or any kind of energy blockages due to the presence of any medium. So that's why the radiation transfer takes place more efficiently in vacuum, though there are other factors which we will discuss laterly when we discuss radiation in detail. The governing equation of the radiation is given over here, and again it will be discussed in detail in lecture 4 part 1. So this is what we have, the different modes of heat transfer. Now mostly these three heat transfer modes takes place at the same time. Now if you burn something and you put an iron rod over here, so here if you see, the heat transfer will take place through conduction, right? Because of the direct contact. You see, there is direct contact and the heat transfer would take place over here due to the collision between the particles. There is no actual movement of the particles in conduction. In convection, you see that the air particles here would become hotter and they will move warmer and they will move upward due to the density difference, and the molecule will move away and takes the heat away. So in this type, the heat transfer takes place due to the molecular motion and what we call convection, right? So here your hand will also become warmer, here your hand is also become warmer, and if, for example, there is no medium between this source and you, still you would feel that heat on your in your hand, and that's why, because of the heat transfer due to EM waves due to radiation, right? Within the presence of the medium or without the presence of the medium, you will feel that radiation, right? As we have discussed or we have mentioned that radiation occurs within or with or without the medium, though the efficiency can vary, but it would take place. Another example is over here. If you see, from this stove, the heat is emitting through mostly predominantly through radiation, and convection is taking place inside the water, which we have already discussed how this takes place. And this handle is becoming hotter and hotter if you see towards this end because of the conduction. So three things are happening, or three modes of heat transfer are happening in one system or in one region, right? So usually one, two, or three modes of heat transfer are in action at the same time in a particular system under observation. So that is it. What we have discussed is the modes of heat transfer, conduction, convection, and radiation. More details on each of them is coming in the next lectures. Our next lecture will be on conduction, and we are going to discuss conduction in detail. So please do subscribe my channel, hit the bell icon, and if you have any query, please email me on this email address afnankhanhaider@gmail.com. Thank you so much. Do subscribe and hit the bell icon. See you next time. Bye bye.